So, what if one AI could predict the future of, well, pretty much everything? That's the incredible promise behind a new model from Google Research called TimesFM. Today, we're going to break down exactly how it works and what it all means. Just think about it for a second. Imagine a single AI that could forecast your company's sales, a city's traffic patterns, and even how many people will look at a Wikipedia page, all without having to be retrained for each new job. Sounds like something out of a sci-fi movie, right? Well, it might be closer than you think. Okay, so to really get why this is such a game changer, we first need to take a look at the old way of doing things and why forecasting has been so tough for so long. Whether you realize it or not, our world is just swimming in time series data. It's really just a sequence of data points collected over time. We're talking stock prices, patient heart rates, electricity demand. It is literally everywhere. And being able to predict it is absolutely critical for business and science. See, the old way of forecasting was, well, kind of messy. You had to build a custom model for every single problem. You want to predict retail demand? That's one model. You want to predict web traffic? That's a completely different model, probably built by a whole different team of experts. And as you can imagine, that approach just doesn't work at scale. It's incredibly slow, it costs a fortune, and you need a whole bench of specialists for every new problem you want to tackle. So, what's the big idea? What's the fix? Well, the answer actually comes from a similar revolution that happened in a totally different field, language AI. I mean, we've all seen what large language models can do, right? The key insight there was that you can train one enormous model on a massive pile of text, and it learns the fundamental patterns, the grammar of language itself. Then, that single model can go on to do a ton of different tasks without being retrained from scratch every time. And this leads to a really powerful analogy. A language model looks at a sequence of words to predict the next word. A forecaster looks at a sequence of past data points to predict the next data point. When you put it like that, are these two jobs really all that different? And that's the billion-dollar question that sparked this whole project. Could we build a single foundation model that learns the universal patterns, the grammar of time series data itself, just like an LLM learns the grammar of human language? Well, the answer, it turns out, is a resounding yes. So let's meet TimesFM, Google's time series foundation model. So what is TimesFM exactly? At its core, it's a single pre-trained model. The magic word here is pre-trained. It means after it's been trained once on a huge diverse data set, it can make highly accurate forecasts on data it has never ever seen before. And get this, with zero additional training. That's a capability we call zero-shot forecasting. And we're talking big here. The base times FM model has 200 million parameters. Now that sounds huge, but it's actually kind of small compared to a lot of the language models out there today. It was trained on an insane amount of data, over 100 billion data points from places like Google Trends and Wikipedia, plus a good bit of synthetic data just to make sure it saw every pattern imaginable. Okay, so how on earth does it actually work? How does it decode this grammar of time? Under the hood, it's using the same transformer technology that powers all the big LLMs. And while the architecture diagram might look a little intimidating, the core idea behind it is actually surprisingly simple and, really elegant. It really boils down to 3 steps. First, the model takes your historical data and just slices it up into small chunks, or patches. Second, it treats each of those patches like a token, kind of like a word in a sentence. And finally, its only job during training is to look at all the past patches and just predict the next one. You do that billions and billions of times, and it starts to learn the deep, underlying patterns of how things change over time. But here's the really slick part. The model is designed to predict a longer patch of data than the input patches it reads. So, for example, it might look at a few patches of 32 data points to predict the next 128 points. This makes it way, way more efficient at forecasting far into the future, because it can take these big leaps with every single predictive step. All right, so that's the theory. Sounds great, right? But the real question is, does a single model really work for everything? Let's look at the results. The test they set up was simple, but also really, really tough. Take the single pre-trained TimesFM model, give it a whole collection of standard public forecasting datasets it has never encountered before. And the main rule was zero fine-tuning, zero new training. How's it going to do? The results were, honestly, they were remarkable. On the Monash Archive, which is a collection of 18 super diverse real-world datasets, TimesFM came out as the top-performing zero-shot model. It was even competing with models that were custom-trained on each specific dataset. And for the really difficult long-range forecasting problems, the results get even more impressive. Here, TimesFM performs on par with, and sometimes even better than, the absolute state-of-the-art models that were fully supervised. Just to be clear, those are models that were specifically and painstakingly trained for these exact tasks. For a general-purpose model to do that right out of the box, that is a huge deal. You know, this quote from the research paper really just nails it. They point out that while you can try to use a general-purpose LLM for forecasting, a specialized foundation model like TimesFM, trained only on time series data, gets much better performance at a tiny fraction of the computational cost. So let's bring it all home. What's the big takeaway here? What does all this mean for the future of prediction? Well, for one thing, the progress is happening at lightning speed. The first version of the model could look back at about 500 data points. The latest version can look back at a context of 16,000 points. It's also moved from just giving simple point forecasts to what are called probabilistic forecasts. That means instead of just spitting out a single number, it gives you a whole range of likely outcomes, which is so much more useful for real-world planning. This technology really democratizes forecasting. It moves us away from a world of expensive, custom-built models to one where powerful, accurate prediction could become a readily available utility, something you just turn on. And that leaves us with a final, fascinating question. Now that we can basically mass-produce predictions, what are the right questions we should be asking next?